So, how exactly does magnetism work? Well, it's simple. It's due to two things: the spin of the electron and the revolution of the electron around the nucleus. First of all, there's the spin of the electron. It's the most important part. If two electrons spin in opposite directions, it cancels out the magnetic properties of an object. This is the case with most of the objects on Earth. They are not magnetic, which means all of their electrons are spinning in opposite directions, canceling out their magnetic properties. However, if two electrons spin in the same direction, the object has an even stronger magnetic field. Next comes the revolution of the electron around the atom. It's basically an orbit. You can kind of compare this to the Earth's orbit around the sun. The Earth rotates on its axis, and that causes the day to turn to night and the sun and the moon to set and rise. And when the Earth orbits around the sun, it causes the days of the year. Next, we'll have some more experiments. Additionally, one of the magnets that we are all familiar with is that of the compass. Watch this short video. As I turn the compass around, the north side of the magnet changes too. But in reality, when I'm standing there, the north side of the magnet points to the same exact place. This is because the north side of the magnet is always going to be attracted to the south side of Earth, and vice versa. The south side of the magnet is going to be attracted to the north pole of the Earth. Two magnets are used here to show the properties of magnets. You can see that when one magnet is outside the magnetic field of the other, it does not attract. But when it is close enough to the other magnet, it automatically attracts to the other magnet. Likewise, the opposite poles of the magnet attract, while the similar ones do not. You can see that the magnet falls down and automatically switches over so that the opposite poles attract. The first experiment we conducted is a common experiment used to visualize the magnetic field surrounding a magnet. For this experiment, you will need iron fillings, since iron is a magnetic material, and these are small shavings of iron that will show you exactly where the magnetic field lines are. You will also need a sheet of paper to put over the magnet so that you are clearly able to see the lines and the fillings don't end up sticking to the magnet. Finally, you will need a bar magnet with two poles. Here we can see that the north pole is blue and that the south pole is red. So the first thing that you need to do is place your sheet of paper over the bar magnet. Once you have done that, you need to take your iron filling bottle, open the lid, and sprinkle the iron fillings onto the sheet of paper, as we can see here. The fillings will start to line up, but to help make the lines clearer, you can gently tap the piece of paper. This will help the fillings shift into the right place. After you keep tapping for a little bit, you will see the fillings shift even more. And then eventually they will line up into the magnetic fields that you will be able to see. Right now, the magnetic field lines are starting to form. Finally, you can see that the lines are beginning in the north pole of the magnet and ending in the south pole of the magnet, just like we learned in class. The field lines outside the magnet are supposed to start in the north pole and end in the south pole, and inside the magnet, they will be going from the south pole to the north pole. I also tried conducting this experiment at home with a circular magnet. I placed the magnet onto a napkin and then placed a sheet of paper over the magnet. Then I took my iron fillings jar and sprinkled it over all around and tried to do it evenly so that the magnetic field lines would be able to show. After sprinkling the iron fillings down onto the piece of paper, you can see that I tapped the paper gently and tried to spread out the magnetic iron fillings so that they would be able to show the magnetic field lines a little more clearly. The results weren't as clear as I had hoped, just like in the animation that I created, but they produced a pretty cool pattern, as you will see in the picture right after the video.